random variables and discrete probability distributions. We're going to begin this lecture by reviewing some topics in Chapter 5, which we are primarily going to be skipping over in this course. There are some topics from Chapter 5 that are critical that we need to discuss, but for the most part we're not going to spend too much time on Chapter 5. So after we go over this review of Chapter 5, we'll continue into the first half of Chapter 6, and then the next lecture will be the remainder of Chapter 6. Okay, probability, as a definition, is a numerical measure of the likelihood that a particular event will occur in the future. So likelihood or chance that something will happen. The probability of an event can only be a number from 0 to 1 inclusive, or in terms of percent, from 0 to 100% inclusive. And when we use the word inclusive, we say including 0 and including 1. 0 to 1 inclusive includes 0 and includes 1. So a probability can be any fraction between 0 and 1, any decimal between 0 and 1, or if you're discussing it in terms of percents, it would be any number between 0 and 100%. So here's some examples. There's a 50% chance of rain tomorrow. That would be equivalent to saying there's a 1/2 chance of rain tomorrow or a 0.5 chance of rain tomorrow. There is a 75% chance that a stock will double in 6 months. And if you know your fractions, 75% is the same as 3 over 4, or the same as 0.75 when expressed as a decimal. The likelihood of the National League Baseball champions beating the American League Baseball champions in the series is 10%. Okay, so 10%, which is the same as 0.1, or 1 over 10. If you spend 2 hours outside of class for every 1 hour in class, the probability that you pass is 90%. Okay, so each of these examples are expressed as percents, but they could just as easily been expressed as decimals or fractions. For experiments such as flipping a coin, rolling a 6-sided die, spinning a 4-colored spinner, you can find the probability of an event occurring with the ratio P, meaning probability, parentheses, event E. So E can represent any event. For example, flipping a heads on a coin. We have in the numerator the number of ways the event can occur, and in the denominator the total number of possible outcomes. So for example, P, the probability of rolling a 4 on a 6-sided die, well, in the denominator we have the number of sides of the die, which are 6, and in the numerator we have the number of ways you can get a 4. Now since there's only one 4 on the die, the probability is 1 over 6. The probability of rolling an odd number on a die. Again, the denominator has a total of 6 because that's the number of sides on a die. And the numerator, the number of ways you can get an odd number. Now since the die has the numbers 1, 2, 3, 4, 5, and 6, there are 3 odd numbers, 1, 3, and 5. So those 3 odd numbers are the number of ways rolling an odd number, the event rolling an odd number, can occur, and over 6 total ways you can roll the die. 3 over 6 as a fraction can be reduced to 1 over 2, which can be expressed as 50% or 0.5. The probability of getting a head on a coin flip. Okay, in our denominator we have the total number of outcomes possible when flipping a coin. You can have heads or tails, so those are 2 outcomes. The 1 in the numerator represents the number of heads on those 2 sides. There's 1 head out of 2 possibilities, so the probability of getting a head on a coin flip is 1 over 2. the probability of spinning a green on a four-colored spinner. So imagine you've got like a game spinner that's divided equally into four different colors, and green is one of the colors. Well, in the denominator are the total number of colors possible that you could spin, which is 4. And in the numerator is the number of ways you can get green. And there's only one green on those that four-colored spinner. So the probability is 1/4. Expressed as a decimal is 0.75. Expressed as a percent is 75%. The probability of an event not occurring, so the probability of not event E is the total number of possible outcomes minus the number of ways E can occur divided by the total number of possible outcomes. Denominator is the same as in the previous slide. So the probability of not rolling a 4, our denominator is still 6 because when you roll the die there are 6 possible outcomes. 6 numbers could come out. The numerator, the probability of not rolling a 4, we're going to think of how many sides of the die are not 4. Well, there are a total of 6 sides on the die, one of which is a 4, so 6 minus 1 is 5. There are 5 sides of the die that are not 4, therefore the probability of not getting 4 is 5/6. The probability of not rolling an odd number. Our denominator again, 6 because there are 6 sides of the die. Not rolling an odd number is basically the same as rolling an even number. Not odd is even. So we take the total number of sides of the die, 6, we subtract the number of odd possibilities, 3, and we get 3, which is the number of even possibilities. And 3/6 can be expressed as 1/2 or 50%. Probability of not getting a head on a coin flip is essentially the same as the probability of the probability of getting tails, which is 1/2. Okay, there's one way to get a tail and 2 possibilities on the coin flip. The probability of not spinning green on a 4-colored spinner. Denominator is the same. There are 4 colors, so 4 possible outcomes, 3 of which are not green. And we get that 3 by taking the total, which is 4, and subtracting the 1 green color, which gives 4 minus 1 is 3. Okay, if you add up the probability of not rolling a 4, which is 5/6, plus the probability of rolling a 4, which is 1/6, you get 1. So the probability of rolling a 4 plus the probability of not rolling a 4 is 5/6 plus 1/6, which equals 6/6 or 1. The probability of not rolling an odd number plus the probability of rolling an odd number is 3/6 plus 3/6 or 1. The probability of not getting heads on a coin flip plus the probability of getting heads on a coin flip is 1/2 plus 1/2 or 1. The probability of not spinning green plus the probability of spinning green is 3/4 plus 1/4, which is 4/4 or 1. So you'll always see that the probability of an event not occurring plus the probability of that event occurring is always equal to 1. Okay, we have to discuss the meanings of the phrases at least and at most, more than and less than. At least n outcomes, where n is a number. At least n outcomes is interpreted as n or more outcomes. At most n outcomes means n or less outcomes, where n equals 0 is a possible outcome. So let's look at an example. If we were thinking about the roll of a die, at least 3 out of a total 6 would include the numbers 3, 4, 5, and 6. At least 3. You include the number 3 when you say at least 3. When you say at most 3, okay, I'm sorry, this is not roll of a die. This is just considering if we had 6 items and at least 3 of those items would mean 3 or 4 or 5 or 6. So if you told a child that they had to do at least 3 good deeds, okay, that would mean 3 or 4 or 5 or 6 if there were a total of 6 good deeds. If you told a child they could have at most 3 pieces of candy, that would mean 0 pieces of candy or 1 or 2 or 3 pieces of candy. So at most 3 includes the number 3, but it's 3 and the number's less than 3. More than 3 is different than at least 3. More than 3 includes the numbers 4, 5, and 6. So if we were thinking of a total of 6 objects or 6 things, more than 3 would include the numbers 4, 5, and 6. Less than 3 would include the numbers 0, 1, and 2. So more than 3 does not include the number 3 when you describe it. 4, 5, and 6 does not include the number 3. Less than 3 does not include the number 3 when you describe it. 0, 1, and 2 do not include the number 3.